Good morning. Today we have lecture number 9, Chemical Kinetics. In lecture we have following problems. First, understanding of rate of reaction. Second, factors affecting rate of reaction. Third, collision theory. And last problem, chemical equilibrium. Chemical reaction require varying lengths of time for completion, depending on the characteristics of the reactant and products. Many reactions are over in the fraction of the second, while others can take much longer. Chemical kinetics is the study of the speed or rate of chemical reactions. Chemical reaction rate is the increase in molar concentration of product of the reaction per unit time of the decrease in molar concentration of reactant per unit time, or reagents. During chemical reaction, reactants are consumed, products are formed. During this chemical reaction, we can see decreasing of concentration, decreasing concentration of starting reagents, and increasing products, increasing concentration of products of chemical reaction. Schematically, we can see this mechanism of chemical kinetics on below. Here, time depend on changing concentration of chemical reagents. For example, gas A and B gaseous substance. The rate of chemical reaction. Chemical reaction rate can proceed in homogeneous and heterogeneous chemical substance. Homogeneous reaction rate, it is change moles of reactants in volume of solution per unit time. And heterogeneous reaction rate is the change moles reactant on 1 meter quadrat surface per unit time. On slide in the below, we can see chemical formula for calculate the chemical reaction rate. Factors affecting the reaction rate, there are several. Can be several. There are nature of the reactant, gas. This is can use when we can take gaseous, liquid, or solid substance. Second, surface area. Third, concentration. Last, temperature and catalyst, and pressure. We can take only in the situation when take gaseous substance. Nature of reactant and products. In organic reaction, a large number of bonds are broken and a large number of bonds are formed. For example, we can use for this situation interaction between sugar and water. In the result, this reaction, we can take glucose and fructose molecules. In ionic reactions, the reactants are in ionic form and no bonds have to be broken up. For example, cations and anions we can take. How surface area affects to rate of reaction. For example, we can take marble. This reaction can proceed between marble and chlorine or chlorine acid molecules, and in the result we can see formation of calcium chlorine molecule and water molecule and gas, carbon dioxide gas. When we take marble piece and marble powder, in this two situation, chemical reaction rate can be various. For example, in the situation marble paste, and the reaction rate can proceed less time. Marble powder, we can take this situation rate of chemical reaction more quickly. In the situation marble paste, rate of chemical reaction proceed more slowly. Law of mass action. In this situation, when interaction of reactant and formation of products of chemical reaction at constant temperature, the rate of chemical reaction is directly proportional. And for example, for homogeneous reactions which occur in one phase only, it may be a gaseous phase or a liquid phase. For example, sulfur oxide plus oxygen, and in this reaction, we can take 2 molecules sulfur oxide. For a heterogeneous reaction which take place in 2 or more phases, for example, we can take aluminum and oxygen molecules. The effect of temperature on reaction rate. This rate of chemical reaction can be characterized by Van Hoff principle. Van Hoff principle said in the temperature range from 0 to 100 Celsius, at the temperature increase of 10 Celsius degrees, the rate of chemical reaction can be increased by from 2 to 4 times. Here gamma is temperature coefficient, is a number including how many times will increase the reaction rate with which increasing temperature at 10 grados. Who does increase the temperature increases the rate of reaction. To rate chemical reaction, the rate of chemical reaction can be affects various situation, various factors. There are collision theory, effective collision, and activation energy. Collision theory states that before any chemical reactions can occur, particles of the reactant have to collide with each other. Activation energy we can need when to start a chemical reaction. When finished this chemical reaction, activation energy is disappeared. Determine the activation energy for determine the activation energy. We can use following formulas, chemical formulas. Here E activation energy. Chemical equilibrium. The irreversible reaction moves in one direction only from reactant to product. For example, kali chloride under heating can give potassium chloride and oxygen gas. The reversible reaction can move in both directions. For example, nitrogen and hydrogen gaseous substance, they both interact. We can take two molecules gaseous substance. On next slide, we can see chemical equilibrium for forward and back reactions, and equilibrium constant. Here Kp, and on the next slide we can see mechanism, graphically mechanism, process of chemical reaction. In the start we can see no reaction occurs. In the middle of chemical reaction we can see reversible reaction. In the in the finished we can see irreversible reaction. On next slide we can see examples for heterogeneous and homogeneous reaction, and for characterized equilibrium 1850 Anil Chatelet was considered Le Chatelet principles. This principle said if a system at equilibrium is distributed by changing the variables such as pressure, temperature, or concentration, then the system will tend to adjust itself so as to minimize the effect of that change as far as possible. factors affecting equilibrium. Many factors can be affects to a rate of chemical reaction, such as concentration, temperature, pressure, and catalysis. Catalyst can be gaseous, solid, and liquid substance. Pressure can be attended when we can take gaseous substance. On next slide, we can see catalyst changing the mechanism, and that's all. Goodbye.